Quasars are one of the most distant, yet one of the most luminous objects known to the mankind. They are super massive in size. But do you actually know enough about them? Watch the video to find out. So without any further ado, let's begin.
So my students, before we begin with our rocky expedition of exploring the mysteries of this universe, let me introduce myself. I'm Professor Kate, a cosmologist, and I firmly believe that space was cool before it mattered. Before we dive deeper into the abyss that the topic of quasar is, let me give you a brief overview. A quasar is an astronomical object of extremely high luminosity, found in the centers of few galaxies, powered by gases spiraling at very high velocity into a black hole. Now, brightest of such quasars can be so luminous that they have the light to outshine all the stars in the galaxy that they are present in. So in a way, quasars are not only one of the most distant but also one of the most luminous objects known to mankind. I can already feel all of your curiosity is piqued up. So let's know about quasars further. Rather, let's shuttle up for an interesting ride. The concept of quasars came into existence in the 1950s, when the earliest of the radio surveys of the sky unusually collided with objects that appeared to be blue stars. The photographs of these quasars showed them to be faint, fuzzy halos, but also had an unlikely resemblance to stars, hence it was dubbed quasi-stellar radio sources. Eventually, the name was shortened to as we know it now, quasars. Now these quasars are thought to be powered by a process called gravitational accretion onto supermassive black holes. Do you know what accretion is, my students? Well, accretion is a theory which states the following. So in virtue, these quasars are powered by gravitational accretion onto the supermassive black hole. And when I say supermassive, I actually mean it. Because some of these black holes can be roughly 1 million to 4 billion times the size of the mass of the sun. These black holes exist in the centers of many large galaxies. And it's a fact that about 5 to 10% of such galaxies also have an accretion disk. Now what's an accretion disk, you may ask me? Well, in galaxies with supermassive black holes at the center, gases tumble into deep gravitational well of these black holes, and then the gases are hosted into incandescence as the gas particles pick up speed and pile up rapidly in form of a rotating accretion disk close to the horizon of the black hole. There are more features which can be found with quasars apart from these accretion disks, like quasar spectra or radio jets. But before we learn about them, let's have a quick recap, shall we? So as you know, my students, quasars are one of the most distant and luminous objects of the universe known to mankind in the 1950s. These quasars are powered by gravitational accretion onto supermassive black holes, and some of these may have an accretion disk as well, which is made of gas particles piling up, which are actually rotating, and the speed of this rotation is calculated using Eddington limit. In addition to the accretion disks and the spectras, quasars have one more uniquely and truly remarkable feature called radio jets. These radio jets, my students, are highly collimated beams of plasma propelled out of the rotation axis of accretion disks at the speed often very close to the speed of light itself. Speed of light, isn't that remarkable? Now these jets emit beams of light only to be observed at X-ray and radio wavelengths. Because of this extremely complex structure, and to say nothing of the cloud of dusts often found near the accretion disks, the appearance of a quasar is subjective and depends largely upon the orientation of the rotation axis of the disk in relation to the observer's line of sight. So my dear students, whenever you would observe quasar different features of these quasars, like the emission line clouds or the jets, may be more or less prominent depending upon the angle you choose to observe. So in conclusion, the observation of a quasar leads to a wide range of observed phenomenon despite having the physically similar sources. I know the topic is a bit complex, my dear students, so feel free to revisit my lecture anytime. It will stay up, unlike the accretion discs of a quasar. Well, it's been a blast teaching you, and that was my last pun of the day. Adios. Like and share this video and subscribe the channel for more of such interesting stuff.